This is Organic Chemistry Video 2. In this video we're going to talk about naming compounds. First we're going to start with rules for naming alkanes. Those are carbon-containing single bond compounds. The compounds are named by finding the longest continuous chain of carbon atoms. The chain doesn't have to be a straight chain, meaning that it can go out and then it can bend down, but as long as it's continuous, that's going to be where we find the parent name. So for example, if the longest chain has 6 carbons in a row, that's going to be hexane. The second step is to identify a group attached to the parent chain. So, for example, groups of carbon atoms branching off the parent chain, those are called alkyl groups or substituent groups. Those are the groups, Katie, that are off the chain, the alkyl groups. An alkyl group that contains one less hydrogen than its corresponding alkane. So, for example, if I was to say methyl, that would be like methane, a carbon atom with single bonds, but instead of having 4 hydrogens as a methane would, it has 1 less hydrogen. Or if we had an ethyl group off the chain, it would be meaning that regular ethane has 2 carbons and 6 hydrogens, but an ethyl group would have 2 carbons and 5 hydrogens. So it has 1 less hydrogen than the corresponding alkane would have. So CH3 is methyl, C2H5 is ethyl, C3H7 propyl, etc. Methyl and ethyl are the most common. A hydrocarbon that contains a halogen substituent, such as fluoro, chloro, iodo, bromo, is called an alkyl halide. Next, you need to remember that you want to number the continuous chain of carbon atoms in the direction that places the substituent group, or the alkyl group, on the lowest numbered carbon atom. Okay, the name of the substituent group and the location number is written first. The parent name is going to be the last part of the name. A hyphen separates the location number of the group and the group name. For instance, 2-methyl. The hyphen is separating the number of the group, the location number of the group, so 2 indicates that the group is going to be on the second carbon, and the group name, which is methyl. If the substituent groups are identical, the prefix di is added to the name. If the substituent group is, there are 3 of them, then you say tri. Tetra means that there's 4. So for example, if you had 3 different methyl groups on the same compound, you would say trimethyl. You list the number. If there are multiple numbers, let's say that there are 3 different compounds that it was attached to, it would be like 2, 3, 4. The carbon that it was attached to. You separate that by commons, but the hyphen for the group name separated by the location. You list the alkyl substituent groups in alphabetical order. So for example, an ethyl group would be written before a methyl group. So here, let's look at an example. Here's a compound. First thing you're going to do, remember, is count the number of carbons in a row. So we have 1, 2, 3, 4, 5. Either way we count, the longest continuous chain of carbon atoms is 5. The prefix for 5 is pent. They're all single bonds, so this is going to end in ane. Off the carbon chain, there is a group up here, and that's called a methyl group. It's a methyl group because it's a 1 carbon group, and the prefix for 1 is meth. It's not a methane group because it's off the chain, it ends in YL, so this is a methyl group. What carbon is it attached to? It's attached to carbon number 2. Well, what if I count it this way? It'd be 1, 2, 3, 4. I'm not going to call it carbon 4, I'm going to call it carbon 2 because if I count from right to left, it's on the second carbon and we always want to give it the lowest possible numbering. So I'm going to call this 2-methylpentane. The 2 tells me what carbon atom it's on. The dash separates the location number from the type of group. And then pent and ane because pent is the number of carbons in a continuous chain, ane because they're all single bonded. Alright, example 2. The longest number of carbons in a row would be 3 if I go this way or 3 if I go this way. So either way, it doesn't matter which way you count, you're going to end up getting the same exact name. So let's say we go this way, 1, 2, 3. So that means that my parent chain is going to be propane. It's ane because these are single bonded. Off the chain, I have a methyl group. The methyl group is on carbon number 2, so we have 2-methyl. Off the chain, we also have a fluorine. So fluorine we call fluoro is the prefix for fluorine, so we have 2-fluoro. How come the fluorine came before the methyl? Is because fluorine begins with an F and methyl begins with an M, and it's going to be alphabetical order for the substituent groups off the main chain. Example 3. The longest number of carbons we have in a row, no matter which way we go, is 4. So let's say I take these 4. That's going to be butane. That's ane because they're all single bonded. Okay, so I'm going to go 1, 2, 3, 4, butane. On my second carbon, I have a methyl group. On my second carbon, I also have another methyl group. So I'm going to call this 2,2-dimethylbutane. 2, 2 because the 2's indicate what position the methyl is on. I have a methyl here and I have a methyl here. So 1, 2 for one methyl, the other 2 for the other methyl. Dimethyl because when you have the same alkyl group, you're going to use a prefix di, tri, etc., indicating how many you have. I could call this 3,3-dimethyl, but 3,3 would be giving it a higher number, and you always want to give the substituent group the lowest possible numbering, so that's why it's 2, 2. Okay, example 4, longest number of carbon chains in a row is prop. Single bond, so ANE on the second carbon. I have a methyl group, so it's 2-methylpropane. Example 5, longest number of carbons I have in a row is, either way we go, 5. So we have 5 carbons in a row, so pentane. On the pentane chain, I have a methyl group on the second carbon, another one on the second carbon, and one on the fourth. So it'll be 2, 2, 4, dash trimethylpentane. The dash, remember, indicates location number from the group, so they're separated by that hyphen. The commas separate when you have the same exact number, the same exact type of substituent group, you're just indicating the place on the chain. So you can take a second to pause the video and try to draw these structures and name these. Okay, let's talk about alkenes and alkynes. Very, very similar. So the parent chain is still the longest continuous carbon-containing compound chain that contains a double or triple bond. You're going to name the alkyl groups in the same way as you did for alkanes. The parent chain now is just going to have the ending ene if you're an alkene and yne if you're an alkyne. The parent chain is going to be numbered to give the lowest position for the double or triple bond, the lowest possible numbering. The number indicates the position just before the double bond or triple bond starts. Okay, here's a picture of an alkene. We have 3 carbons in a row, so it's propene. Here, no number is listed because if I flip the compound over, it would start at carbon number 1. Even if it was rotated, it's starting at carbon number 1. There's no additional place to put it because if the double bond was here, it would still be carbon 1. So when there's literally only one possible position for the double bond, it's not necessary to write the number. So propene, and here's what the condensed structural formula would be, CH2, because there's 2 hydrogens, followed by CH, followed by carbon with 3 hydrogens. In this carbon, there are 4 carbons continuously in a chain, so we get bute. There's a triple bond present, so you have the YNE. The 1 indicates the position of the carbon-containing group that has the triple bond. So here we have, see how the bond starts on the first carbon? Where it starts is really where you're going to give it the name. So it's 1-butyne. You could also say bute-1, bute-1-YNE. It's kind of a different way of doing it that you haven't seen in Regents that you might find more comfortable with. It's up to you. Here's the last example we'll look at, has 5 carbons in a row, so pent. And you could say, remember in the middle of the compound where the double bond is. So this would be pent is starting on the second carbon because we want to give it the lowest possible numbering. It's starting at second in between the second and third. So pent-2-ene. We also have a methyl group in this compound, and the methyl group is also on the second carbon. So we would say 2-methylpent-2-ene. So in your notes, just draw a picture of the following compounds as best you can. It's nice being able to use this structure of the system, because that way we know where the other alkyl groups are and where exactly the position of the double bond is. Otherwise it might get a little tricky.